Alright, so what I'm presenting today isn't actually Ruby specific. It's about command line tools that um, people from developers of using different programming languages can use. Um, so in particular, uh, I'm gonna provide alternatives to these three common command line tools. So ls for listing files, grep for pattern searching, and find for finding files. So these are the tools that I'll be talking about. So this talk is split into three sections. So it's like three small talks about these three tools. So you list files hundreds of times a day. Why spend your time squinting at black and white text? So the first tool that I'm going to talk about is Exa. It's a modern replacement for ls. So this this is from the Exa website. So Exa is an improved file lister with more features and better defaults. It uses callers to distinguish file types and metadata. It knows about symlinks, extended attributes, and Git. It's small, fast, and just one single binary. So this is the outline of my small talk about Exa. We'll be talking about different views, how to install it, and so on. And this is a preview of the output of Exa. So here at the top, you can see it's the grid view. When you do ls, the files are displayed in columns, so that's also the default for Exa. And then, like ls-l, so the long view, Exa also has Exa-l, and it displays more information about each file. And at the bottom here, it's just a sample of Exa providing a lot of flags to the command. So here it's displaying, it also displays the dot files, it has the header. So if you look at the top, there's like column headers describing what each column is for. The file sizes are displayed in binary, so KB instead of kilobytes. Displays inodes, the group information, system blocks, and so on. So this is so Exa displays the files in grid by default, and each special type has a different color. So you can see that a directory is blue, the executable is green. Regular files, actually different regular files also have different colors, but by default they're white. And then you have a named pipe, a symlink, and a socket file. So here we're seeing the different colors of different file names based on their name and file extension. Temporary files are gray, and then Exa also has a way of like if a certain file has the same file name but different file extensions, it tries to figure out which ones, like the source code, and which ones are compiled, and so it dims the color of the compiled files. In this case, it even considers .js as compiled because there's a .coffee file. And then we have the red archived or compressed files, cryptography files, document files, and it's not very visible here, but the image files are actually darker purple, and then the audio and video files are brighter purple. And Exa also has what it calls immediate files. So here makefile is like highlighted, and for Ruby like folders with a rake file, it actually also highlights the rake file in a similar manner. So these so if you have other file extensions that's not included by Exa, you can extend them, and you can also customize the color, or you can also disable the color if you don't like, although in that case maybe use ls instead if you don't like the colors. And actually in Linux and Mac, LS has a colored version. So for Mac, if you pass -G, you can also colorize the file names, but as far as I know, the metadata information for LS are not, there's no option to output them with colors. So for EXA, these are also colored by default. So you can see the permission bits and the file size, they have different colors. So the header displays the column, like the column names, like the permission size user at the top. So as far as I know, there's no option for this in LS. We can discuss later if you know about a way to do that, but as far as I know, there's no like feature flag for that. And then yeah, the file sizes are human readable by default, so you don't need to pass -H as you do in LS. So here you can see it's in megabytes and kilobytes, and then you can also list the specific files that you want to just be displayed. And then here's a sample output for different timestamps. So by default, the date modified is displayed, but if you need the other date information, timestamp information, you can pass the modified, create, and then accessed options. And this is one of the nicer features for people with widescreen displays. You can combine the long view with the grid view. So files are displayed in columns, but you also see the additional information for each file. So this is the tree view, and the level is specified, so it only goes down 2 levels. So it's the recursion depth. And then as in the long grid view in the previous slide, you can also do a long tree view where it's displayed in a tree layout, but you also see the other information. So it also has Git support. It only displays M and N basically. So for M for modified and N for new files, and there's a Git label at the top. So if you're running on Mac, you can install it with Brew, just like that. And then in the website, it only says Windows support coming soon. And then it has Linux support. So you can check the EXA website. It has instructions for different flavors of Linux, Arch Linux, Fedora, Gentoo, and so on. And so there's actually a funny issue in the GitHub repo where they're discussing that 3 characters is too long. So some people are just recommending to alias it, but others are obviously asking to make it the default. But the consensus seems to be to provide, or to at least use an alias of XS, XL, and XA, similar to how people alias LS, LL, and LA for LS-L and LS-A. And then some are even suggesting just 1 character. So that's the EXA part of my talk. So next is, so for both searching single files and huge directories of files, no other tool obviously stands above ripgrep in either performance or correctness. So this is an excerpt from Andrew Gallant, the author of ripgrep, his blog post where he discusses the project in detail. So ripgrep is a line-oriented search tool that recursively searches your current directory for a regex pattern while respecting your git ignore rules, and it has support for Windows, Mac, and Linux, and binary downloads. So this is the outline for this section of the talk. We'll be talking about the basics and the other features, and also the performance later. So I'll be doing a comparison of the output of grep and rip grep. So for grep, on this slide, you're searching for the word handby key on the README file, and this is the output, and this is the output for rip grep. So the command is rg, and then you can see that there's a line number colored green on the left, and the keywords are highlighted red. So in grep, there's actually a dash color option to also highlight the matched text in red, and there's a -n to display the line number for grep, but I think it's not colored. So if you use grep -n, you'll also have the line numbers, but it's going to be white. So this is more easier on the eyes. And then here is an example of grep when you're passing the -e, and then to use extended regular expression, so you can use like the plus special symbols. So this is just an oversimplified regex for an IP address. So it's very loose and not exactly an IP, but it works for this use case. So it also checks the README, and this is the output. So this is for rip grep, and if you notice, there's no need to pass an extra flag. So there's no -e for extended regular expression. It basically accepts regular expression by default, and you can still see the line number in green and the highlighted text, which is nice. For recursive, in grep, you pass -r, and in this particular project, in this use case, we're trying to exclude the target directory, which has files that we don't want to look into, because maybe there are a lot of build output there. So we pass exclude their target, and then the string that we're looking for, and then at the end there's a dot to indicate that you're searching from the current directory, and that's the output. So for rip grep, so first you'll notice the colors, and it's grouped by files, and there's no need to pass a recursive flag because it's recursive by default. You don't also need to specify the current directory, because if you don't pass any paths, it will check the current directory by default. And there's no need to exclude the target directory, because rip grep has a feature which is automatic filtering. So by default, it automatically filters out files and directories that match the rules in git ignore, and then hidden files and directories, so dot files, and then it also filters binary files and symbolic links aren't followed. So actually 3 and 4 is also the default for grep, but it's items number 1 and 2 which are new. So you can disable the automatic filtering, so you can pass no ignore, so that git ignored files are still searchable, and then -- hidden, so you can still search the hidden files as well. And then for the third item, that's for the binary file. So this is exactly the same as grep, so -- text or -a. And then for symbolic links, I think follow is the same as grep, but for the single character, it's -l for rip grep and -s for grep. And then alternatively, you can use the unrestricted so if there's just one -u, that's equivalent to the no ignore. And then for -uu, so it's not no ignore and hidden combined, and then the triple U is for the first for 1, 2, and 3. if you want 1, 2, 3, and 4, you also need to add -L. So -UU, since grep doesn't have the git ignore and hidden file automatic filtering, that's like equivalent to grep -R for recursive. So, and the triple U is roughly equivalent to grep -R-A. So recursive and then -A for the third item for binary files search. And then, so if you want to search by file type, the first way is to use the glob option and pass the *.rb pattern, so it only searches for .rb files. But there's also the --type Ruby, where it's not just RB files, so it actually includes those files: gemspec, IRBRC, gemfile, and rakefile. And the third one is just the same as the second one, so truby. And then you can actually list all the different file types supported by ripgrep, and here I'm just showing a way to define a custom one. So after you define the path to your config file, you can add the following. Like in this case, you're adding a custom web type and specifying .html, .css, and JS. And so you can just like type web, and then you're basically just searching those types of files. So this is about file encoding. So character encoding is a complex topic, so I won't be discussing it in detail. We can discuss after the talk later if you're interested, but I'll just try to briefly describe how ripgrep works with regards to file encoding. So it assumes that the input files are ASCII compatible. So like if it checks the byte and compares it to the ASCII code point, even though the byte may not necessarily be ASCII and it might have a custom encoding, so ripgrep doesn't distinguish that, just compares the code point to the byte. And ripgrep works best with UTF-8, and it actually has a feature where it checks the file if it's in UTF-16, and if it is, it converts the entire file to UTF-8 before it finally executes the search on that file, since it works best in UTF-8, so it converts UTF-16 to UTF-8 automatically. And if you have a custom encoding, you can pass --encoding to ripgrep, and it actually doesn't require UTF-8. So for example, if you force the search on a binary file and there are like UTF-8 code points in there, then ripgrep will match those, even though they may not necessarily be actual UTF-8. But it doesn't, if the file is not not purely UTF-8, that's fine. And then you can still disable Unicode support if you like, because for example, so in regular expression, when you have dot, that's like one character, right? But for example, UTF-8, that can be 1 to 4 bytes internally. So if you want dot to just mean 1 byte, you can disable Unicode support, and a regular expression dot will just mean a byte basically. And this is discussed in detail in the guide document in the website, in the GitHub repo. So for performance, rip grep at the top is the fastest. So this is actually just I copied this data from the README of the project, and there's actually I think a blog post article with a lot of benchmarks, and not just for a few cases, but this is just like one benchmark that's used in the README. This is searching the entire Linux kernel source tree. So yeah, this is the number of lines matched, and actually there's like, oops, the app is misbehaving in that it's matching a lot more lines than it should, so there's a bug there. And then, sorry. And then these are a lot of the other tools that you can use. If you're familiar with git grep, there's a grep feature in Git, so you can only search like the cracked files. So rip grep is basically like git grep, right? So it ignores the git ignore by default and only searches the tracked files, sort of. So yeah, it's 5 times faster than git grep, and even more so if you use Unicode for git grep. And then this is for the, I think the ultimate code grep is UCG. I'm not familiar with UCG actually. And then grep is at the bottom, and yeah, the performance is very there's a big difference in performance. And here is just rip grep and grep, and this is actually searching a 9.3 gigabyte I think text file. So, and it searches for Sherlock, and there's a lot of lines matched. I think if you add a line number, rip grep becomes 2.6 seconds and grep becomes like 10 seconds. So the difference in performance is quite big. So yeah, if you're using Mac, it's similarly very easy. Just brew install, and then also has Windows support and Linux support. So that's rip grep. So next, the last section of my talk. So while it does not seek to mirror all of Find's powerful functionality, it provides sensible, opinionated defaults for 80% of the use cases. So FD, it's actually quite popular. I noticed it has 7,337 stars in the GitHub repo. So FD is a simple, fast, and user-friendly alternative to Find, and the command name is 50% shorter than the Python. It's mentioned in the README as well. So this is our outline for this last section. So yeah, so first, this is Find in the current directory, and then -i name, I for case insensitive match, and then you put asterisk before and after config, so it matches that pattern. And then if you notice, this includes a directory that's generated by gitbook and also the .git. So for FD, those two aren't part of the output. So you don't need to pass the current directory by default. That's also the default directory that it checks, and then there's no need to pass -i name because the string passed is also a pattern by default, and you don't need to put asterisk. And yeah, the output is colored if you noticed. So here, this is fine if you want to exclude the .git and the book path. So it's quite complicated. So you're escaping the parentheses and then using the dash path and the or. So it's either .git or underscore book, and then you prune that, and then you just search the pattern and then print it. So it also has automatic filtering as mentioned. So folders, and it also does not show the files that match the .git ignore patterns, and then hidden directories are also not shown and or searched. And you can disable automatic filtering with these options. So no ignore to ignore.git ignore, and to find hidden files, you use -- hidden. So here, if you want to provide a path, so you pass it as a second argument, and it actually has a different color. It highlights the etc directory, and then the directories are in blue, and then the matched files are, the found files are just white. So it I mentioned earlier, it's a pattern by default, so it's already a regular expression by default. And here we're searching for files that start with the letter C and ends with RS. So these are the matched files, and yeah, it's colored and highlighted. So you can also search by file extension. This is for searching markdown files. You use the -e option. For performance, I'm getting the benchmark by the author. It's just one benchmark. It's not like the RIP grep where he did a lot of benchmarks and has a whole article about it. So this is just one benchmark for 190,000 subdirectories, 1 million files, and the details are in the README. So there are 4 different cases. So find with regex and find without regex. So FD uses regex by default, so there's no without regular expression. And then in the third case, FD uses the hidden and ignore, so that it's the same as find, because find doesn't ignore hidden files or the git ignored files. So absent that automatic filtering, you can check the first 3 results. So it's still faster. Even the find without regular expression is about 4 seconds, and FD is just 800 milliseconds. And then if you use the FD that does the git ignore and hidden by default, then it's even a lot faster. So as the other 2, for Mac, you just brew install FD, and it has Windows support and Linux support. So yeah, as a recap, these are the 3 command line tools discussed. These are the links to the websites, and there are actually some sections in those websites, like in RIP grep. It describes why you might want to use it, and what cases where it's not a good fit maybe for you, so it can help you decide if you want to use it or not. So the 3 tools are actually written in Rust. So I'm a Ruby developer learning Rust, and that's how I found out about these 3 projects. You can follow me on Twitter, and you can check my projects in GitHub. And are there any questions about the talk so far? Or anyway, you can approach me later after the presentations. So that's it.